in 6.2, where it talks about rational, when we have to deal with rational exponents. So notice what our learning goal is for today, and it'll be the same learning goal probably tomorrow and even Wednesday. I can evaluate and simplify expressions with rational exponents. Now, all the properties of exponents that we've already learned are not going away. What you learned in 6.1, you're going to have to keep using now. But then we're also going to have to deal with what do we do when we have a rational exponent. What does rational mean, first of all? What is it? When we say a rational exponent, what should you visualize? Well, not necessarily, it doesn't have to be positive. That's what rational means. It doesn't have to be, it will not be a whole number, but it could have a whole number part. Rational, think of a ratio. What's a ratio? What's a ratio? Comparison of one thing to another. And how do we typically write that comparison? In what form of a number? Well, it could be, sometimes they can be changed to a mixed number, and other times they can. We take a 4-day break and our brains go dead. Ratio. Comparison of one to another can be written as a fraction. So rational has the word ratio. And so what we're talking about when we talk about rational exponents is we're saying you're now going to have powers that the exponent is a fraction. How are you going to deal with when you have a fraction as the exponent? So let's start right here. It says when we have this little n written inside of our radical sign and then the b underneath it, that really means the same thing as b to the 1 over n power. B to the 1nth power. They mean the same thing. And here's what they really are asking. What number times itself n times is b? So that little n that is there, that is what we call the root. What number times itself n times is b? N is the index. That's another term you'll hear it called as. It's the index.
Ms. LeGrand?
Yes?
Could you send me and Cassius to the office?
I can.
Thank you.
And tells us which root of b to find. So n is called an index, and it's asking us, say, here's which root of b we want you to find. Okay, so let's use it when we don't have like those abstract variables involved. Let's just actually do one where we have 8 to the 1/3 power. 8 to the 1/3 power, when you see that and it's asking you to evaluate that, it is asking for the third root. That's our n value. Our n is 3 this time. Of 8, 8 is our b value. It's our base. So it's asking for the third root of 8, which really means what number times itself 3 times is 8. We were just doing that at the beginning of class when we were talking about our powers table. Is there something multiplied by itself 3 times, taken to the 3rd power, that gives you 8? Shmarky?
2.
2. Yeah. 2 times 2 times 2. 2 times 2 is
4.
4, and then times 2 again is 8. So 8 to the 1/3 power is actually 2. 2 is the third root of 8. So 8 to the 1/3 power equals 2. Now we can actually get that on our calculators. We can actually do that. Let's see if it works. Will you grab your calculator, please? You're going to show me how to get there, but I want you to verify that we know what we're doing here. So when 8 is your base, so you put that in. We're going to take it to a power, so we say 8, and then use your power key raised to the, or the y to the x key, whichever one you use to raise something to a power. Then I want you to put in parentheses, I want you to put a parenthesis, 1 divided by 3, that's what the fraction 1/3 is. 1 divided by 3, close your parenthesis, press enter or whatever you do to evaluate. Okay, yours just puts it there. Okay, and then what do you get?
2 times 2.
2. Okay, so 8 to the 1/3 power is 2. It's asking you what number times itself 3 times gives you 8. Okay? Okay. Let's go on and do the second one here. 81 to the 1/4 power. What's that asking us for? The 4th root of 81. It's asking for the 4th root of 81, or in other words, what number times itself 4 times is 81. So here's what we're going to do to show work. We're going to say what times what times what times what equals 81. Or what raised to the 4th power equals 81. Isaac?
3.
3. Should be in your powers table. 3 raised to the 4th power equals 81. Is that true? Okay. So 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So we're going to say that 81, and there's our work to support it. 81 raised, oops, that's a big 1/4. That doesn't even look like a power. I need to erase that. 81 raised to the 1/4 power equals 3. 81 to the 1/4 power is 3. If you put it into your calculator, it took 81, raised it to the 1/4 power. It should give you 3. Okay, so you have a couple of different ways that you could show this. You could do like I did right here. You could show the 4 blanks that we had to fill in and say to get to 81, and then you can give your answer. This would be your work right here. Or I would let you show the work like this, showing that you have a fill in the blank to the 4th power equals 81. You go to your powers table, you look, and you see that it is 3. So your fill in the blank answer is 3. And then you can say 81 to the 1/4 power is 3. So we have 2 different ways you could show the work there. You don't have to show them both though. Anybody got questions about that? Okay, let's go on to number 3 then. We have 121 to the 1/2 power plus 256 to the 1/4 power. I'm pretty sure that's what it says there, but my thing kind of covered it up. 256 to the 1/4 power. Notice what I did. I want us to get used to also that we might see it written with the radical sign rather than the fractions. So 121 to the 1/2 power really means the same thing as the square root of 121. Because 2 is our index right there. And that's the only index that they never show. Typically they leave it out. It's in the invisible one. We've gotten really used to when we see the radical sign, we don't even have to think twice. We say the square root of. Because we know that that invisible index right there is a 2. So here is how we can write it when we write it in its radical form, this is called. And notice 4 is the index. This time we have to show the 4 because we don't want it to mean 2. So the 4th root of 256. So this is really asking for the 2nd root of 121. And then I want you to make that plus sign in between there a lot bigger than I have it. Plus, saying find the 2nd root of 121. Add to that the 4th root of 256. That's really what that's asking us to do. So we need to find what squared equals 121. And we need to find what to the 4th power equals 256. And then we're going to add those together. So, what squared in your powers table is 121. Is there anything? Did we not get it that far? Okay, so shoot, I was gonna make a new powers table, but because of everything going on in my life right now, I didn't get time to, so I just used the old one. Anybody know what times itself is 121? 11, yeah, it's 11. So 11 squared is actually 121. And what in your powers table to the fourth power gives you 256? 4. Everybody agree?
Yeah.
Is 4 to the fourth power 256? Okay. So now what we just found, we found the second root of 121. We found the fourth root of 256. So we're going to add those together and say that the final answer is what?
15.
15. Here's our final answer, 15. We had to find the square root or the second root of 121. We had to find the fourth root of 256, and then we had to add them together. That's what the problem was asking in the very beginning. So questions about that one? Okay, then let's move on to our next one where we have a subtraction problem going on. Let's practice renaming them with the radical sign. What would I put underneath the radical sign? What goes under there? The 27. Can I leave it blank? Do I have to write the index or can I just leave it? I have to because it's what is the index?
3.
3. So we have to put a little 3 there. Okay, what's going on under the radical sign for the other one?
5.
No, 1 is the base. The base always goes underneath the radical sign. And the 5 is the index or the little number in the outside of that radical sign, kind of in that little B part there. Okay, so this is really looking for the third root of 27. And we're supposed to take away from that the what? What are we supposed to take away from that? The fifth root of 1. Okay. That's as good as that. Okay? So we're looking for what to the third power is 27. And what to the fifth power is 1. So what to the third power is 27? 3. And what to the fifth power is 1? 1. So we are going to have 3 take away 1, and that is, so let's circle these so you know that that's what you found here, and that is 2. So our final answer is 2. Again, if we would put it in our calculator as 27, taken to the 1/3 power, we'd press the subtraction key. We put in 1 taken to the 1/5 power. Our final answer should end up 2. So any questions? So these last 2 problems, we were not only evaluating what a power is with a rational exponent, but then also doing an operation. Number 3, we were doing addition, and then in number 4, we were doing subtraction. Okay, then let's go to the back and see what I have for us to do back here. Woo, this looks like fun. A fraction being taken to a fraction power. So, what did we learn that when you have a fraction to a power, what can you do? Don't even worry about the fact, don't even worry about that we have a fraction power. Just tell me what we can do when we have a fraction to a power. Or in other words, a quotient to a power. Cameron?
Give the power to the hundreds at the top and bottom.
Yeah, give each of them their own power, which is what I already did for us. I wrote it as, I said give the numerator that 1/2 power and give the denominator that 1/2 power. Well, 49 to the 1/2 power means what? What does that really mean? No, I don't want to know what it is. What does it mean? 49 to the 1/2 power means what, Brighton?
49 in the radical part and 2 as an index.
Yeah, so we're taking the square root of 49, and we're taking the square root of what? 81 downstairs. So we're taking the square root of both of those. Or in other words, we're finding what times itself twice is 49. 7. What times itself twice is 81? 9. Can 7/9 be simplified?
No.
No, so we would say that is our final answer. Okay, so that was one way of showing work for that one. If what you would rather do instead, I'm just going to go up, I'm going to come over here and I'm going to say if I went from 49 to the 1/2 power over 81 to the 1/2 power, I could show it like this. What times itself is 49, and then I'd have to have another big fraction mark here because that was just to fill in the blank spot. What times itself is 81, and I would say, okay, well, what times itself is 49? It is 7. What times itself is 81? It is 9. So this is what I was looking for. I would still get the same answer, 7/9. So the way that makes sense to you, use that way to help you show work and get the answer. Don't let your calculator just do it. I showed you that the calculator can, but this would be a little bit trickier to put into your calculator. You need a whole bunch of parentheses to keep everything straight. It'd be more challenging anyway. Okay, why don't you try number 6 then on your own. Try number 6 on your own. Decide which way you want to show the work. The red or the blue. You have your choice. Again, the first thing though I want you to do is I want you to give both the numerator and the denominator their own power. What's our answer to this one? Isaac, what'd you get?
I got 1/4.
Okay. Anybody want to agree with Isaac that the final answer to this one is 1/4? Okay. So that is correct. It is 1/4. Or in other words, when we're all done with it, we should be able to say this multiplied by itself 3 times should take us back to 1/64. Would 1/4 times 1/4 times 1/4 get us back to 1/64?
Yeah.
Because 1 times 1 times 1 upstairs is
1.
and 4 times 4,
16.
16 times another 4, 64. We would have a 64 downstairs. So this, as a root, in other words, this multiplied by itself 3 times would take us back to our base that we started with. So we should have the correct answer. Now, pay attention to what I'm going to show you right now. Everybody needs to show on a problem like this, you need to show giving both the numerator and the denominator their own power. And then you have 2 choices of ways to show the work. The green, where we do it with a radical sign, or the red, where we say, what do I have to do to fill in the blank? I have to say, what times itself 3 times gives me 1, what times itself 3 times gives me 64, and that's how I can come up with it. So we have either the green or the red. Okay, so you have to do this one, and then you have to pick one of these to show as your step of work before you get your final answer. Okay, anybody got questions? Okay. Go ahead and try one more then, see how you do. Stefan and Trey and JC, you guys are all done already? Okay, who's my volunteer to come up and do it here on the, okay. Trey, you can do, Trey, one of you do it on the smartboard, the other one do it over here on my whiteboard. Hoping you both have different ways of showing the work. Okay, and you can't, you gotta write so that you fit on there. Here, let me change, I wanna change the, okay, it's gonna be black, that's cool.
Do you see my hair's too big?
Ted's like, you're like using your finger better than the pen, see what it's doing. I don't know why this board just likes that.
So just use my finger.
Yep, just use your finger as if it's the pen.
Now it's blue though, is that okay?
Totally fine. But that's a really big four, that should not be that big, okay?
Do I do like this? Erase
No.
How do I erase?
How about I just,
Okay.
try again. Okay. And of course, they had to show work the same way, but that's all right.
I don't. It's not that big. Come on now.
It looks like we were multiplying by 4, doesn't it, class? It doesn't look like an index. We have to be careful with those. So that is going to be important, that index is small and in the crook of that radical sign, not out front of it, because that would mean multiplication out front of it. And there can be multiplication out front of a radical sign, okay? So we do have to be careful about that. But it is kind of hard to do. I get that. You have to just start, just like we make exponents, we make those smaller than we do the rest of the problem. Okay, thank you. Okay, so they both did it the same way, both got the same answer. How many of you agree with them? Could we give another name to this one? Go ahead, okay, Brighton.
1
1 1/2. Another name, possibly, that would maybe show up in an answer bank. 1 point. No. 1 1/2 is the same as 1.5. 1 5/10. Yeah. So we just have to make sure we understand there are other names for this also. But yes, this is the correct answer. 3/2, and you can just leave it 3/2. You don't have to rename it. Okay. Go ahead, JC.
Are all the answers like for today's like gonna be in here?
We hope
You know,
so.
use our calculator.
We hope so. If you have to, it's all like we had that one, we needed to find out what times itself twice is 121. You might have to actually, play around with your calculator to get that one, but, okay? So any other concerns before we get started on homework? Okay,